in what kind of situations would relative motion be useful? Well, one example is a policeman who's trying to catch people who are speeding. A lot of times you'll see the policeman sitting out on the side of the road. So they've got their police car right here. They're in there, they're shooting their little speed gun to catch people who are going by. Well, sometimes the policeman can even do this while he's driving. So let's say the policeman's on the road, and then here comes Bob in his red sports car. He's just whizzing by. Got this little aerodynamic thing on the end. Okay, so Bob is flying by with some velocity VB. The policeman is going the speed limit with some velocity VP. Say that's the x-axis. Well, the policeman, say his VP equals 60 miles per hour. And when Bob whizzes past him, he clocks Bob at VB relative to policeman is 20 miles per hour. So how fast is Bob actually going? We know velocity of B equals velocity of P plus velocity of B with respect to P. That equals 60 plus 20 equals 80. So we know Bob was going 80 miles per hour, and the policeman could tell because he could clock that relative speed relative to himself. Well, this is one-dimensional, but what if it's two-dimensional? Because in real life, most things are at least two-dimensional. So let's say policeman's driving through the neighborhood. So here's the policeman shooting his little speed gun, and he is moving with velocity VP. Now there's a cross street here. Cross street goes on the y-axis. The policeman street goes on the x-axis. Here comes Bob whizzing through the intersection with velocity here, VB. So let's say Bob's velocity is 40 miles per hour, and the policeman's velocity is 30 miles per hour. So what is the velocity of Bob relative to the policeman? Well, we know velocity of Bob relative to policeman equals velocity of Bob minus velocity of policeman. But in this case, the velocities are actually vectors because we have coordinate axes, they're going in certain directions. So velocity of Bob is going to be 40 miles per hour in the negative y direction. So we'll have negative 40 J. And then we subtract velocity of the policeman. So minus the velocity of the policeman is 30 miles per hour in the x direction. So we'll have 30 I. So this is velocity of Bob relative to the policeman. So if we wanted to know the speed, just the scalar, vb with respect to p, then we take the square root of the x squared plus the y squared, which is negative 40 squared plus negative 30 squared, which equals 50. So velocity of Bob relative to the policeman is this. The relative speed, which is a scalar, is this.